Hi, this is the first in a series of videos on introduction to programming in Python. This series of videos is basically to introduce you to the syntax, the basic principles, and the features available in the Python programming language. I will assume that you have programmed in some language previously, maybe in C or C++ or MATLAB or something similar, but perhaps are not so familiar with Python syntax itself. Unlike C, C++, or MATLAB, Python is an interpreted programming language. The syntax could be a little bit different. There could be some features which are there in Python which were not there in C, C++, MATLAB, or so on. Uh, this is just to get you started to program in Python, and is no in no way is going to be comprehensive. It's going to be a very quick crash course on programming in Python. Uh, that being said, for you to be able to solve problems effectively using Python or any other language, you need to be able to think like a programmer. You should be able to solve problems, and the only way you will acquire that skill is by solving a lot of problems. And that is the only way you will learn to program. So take up a project, try to work out some examples, code on your own. Right, that's the best way to learn any programming language. Uh, so this is mainly to introduce you to all the features. Now there are a lot of online resources available for Python, and this series is just to quickly get you started, because sometimes just getting started takes a lot of time. So hopefully once you learn the basics, you can use other books, other tutorials, other videos, and hone your skills. So about the Python programming language itself, it's an extremely easy to learn programming language, unlike C or C++. It's a general purpose interpreted programming language. It's not compiled, unlike C or C++. So in terms of pure compute speed, Python is not so great. But you make up for that in terms of convenience and ease of programming. So if you want to implement something quick, let's say you want to simulate a communication system in Python, it's going to be far more easier than simulating it on C or C++, purely in terms of the number of lines of codes required. Also, there are a huge number of libraries available for various purposes. So it makes it extremely easy to code. And also in recent years, there have been a lot of specialized libraries developed, particularly for applications such as machine learning, which effectively use the GPU. And so Python code written, which are specialized for GPU implementations, are going to be much faster than C or C++, which mainly use the CPU. So in particular, certain operations are optimized. So particularly vector and matrix operations. So these are optimized in Python. That's of course if you use certain libraries. And we will learn a little bit about that. So unless you use these specialized libraries, your code will in general be much slower in Python than in C or C++. There are some tricks in order to make your code run faster. But of course, our focus is not going to be in terms of speed. It's mainly going to be ease of programming. Right, so we're not going to worry about how fast our code is for the time being. You'll only see what features are available, but a lot of resources are available online, and I encourage you to look at those. Search Google. Google is a great reference search for all of these things. All right. So Python can be downloaded from this particular website. There's a website for Python. It's an open source programming language. You can go to python.org. There's a lot. You can download the software from that. There's a lot of documentation available. But there are different ways of installing Python. If you want the latest version of Python, then you can go to python.org and download this. If you're using, say, Linux, you can use your package manager to install Python. So for example, if you're using a Debian-based Linux distribution such as Ubuntu or Linux Mint or Debian, then you can just do something like sudo apt install Python. But I would recommend that you use a different approach instead of using instead of either downloading on python.org or using your package manager. It's more convenient, and I would say it's recommended to instead install using what I call Anaconda. So Anaconda is sort of a package manager for Python. It helps you install packages very easily, and it has a host of other features that are extremely useful. So you can go to anaconda.com and basically download Anaconda. Note that this is going to be a fairly large file, so it downloads a script. Depending on your operating system, you can download the installer of your choice. I already have Anaconda installed in my system, so I'm not going to do that. But you can basically installing this on a Linux-based system would basically amount to downloading this shell script file, and then maybe going to the terminal. You go to downloads and something like sudo sh anaconda. Exactly the file name that you've downloaded, and then enter. It's going to maybe ask you a couple of questions. Just say yes to everything, and it's going to install in the default path. The installation instructions would be slightly different depending on the operating system that you're using, and all of these details can be you can just get all of this in anaconda.org. Right. There's also an easier way to sort of use Python without installing anything on your system, and the way to do that is using what is called Google Colab. So go to Google Colab, basically colab.research.google.com. You will have to log in using your Gmail address, and basically it lets you it gives you an environment to run and to basically write and run Python code. So for example, you can create what is called a Jupyter notebook. As I said, Python is an interpreted programming language. So unlike C or C++, where you write code in a file, and this file and the associated libraries have to be compiled, Python is sort of converted to machine code line by line. So that also makes it easy to sort of get started with. I don't necessarily need to create a separate file and compile it every single time. As long as I have the Python interpreter installed, that is fine. So in this case, the Python interpreter in Google Colab is going to be on the cloud. It's not on my system. So suppose I just want to execute some lines of Python code. Perhaps I want to print something. All I need to do is type print hello world, and then press this little button over here. It is going to execute this particular code. All right. Now, Google Colab is of course free. There are some advantages and disadvantages of using Google Colab. The advantage is that you don't need to install anything on your system. The disadvantage, perhaps in some cases, is that you're using these compute resources for free, right? So all of this is being hosted on the cloud, and at times it can be much slower than executing it on your own system. However, there are also paid versions, for which you can sort of buy additional compute resources and GPU resources, and that makes implementation much faster. Also, if you have a very old system and you're not able to execute a lot of Python code, maybe it's too much strain on the compute resources that you have, then you can use Google Colab, right? So in principle, you can use Google Colab even in on a tablet or or your phone also, right? Because all you need is a browser. You just need to log in and use Google Colab. So but at the same time, it's also helpful to know what are the different ways of writing and executing Python code, because sometimes you may have to use perhaps maybe you want to run it on a system which is in your lab, which has additional compute resources. You may want to execute it on your laptop, or you may also be wanting to execute it on a remote server. Right, so you should know what are the different ways of writing and executing Python code. So I will not be using Colab for a lot of things, but it's a very popular way of running Python code. Right. So as I mentioned, there are different ways of running Python code. If you installed once you have installed Python, you can effectively just create a file, a .py file. So all Python files are typically have the extension .py. So if I want to say write a few lines of code, perhaps I just want to print hello world, then one way I can do this is I create a text file. You can do this in any text editor of your choice. It could be Notepad or Vim or Emacs or anything else. So I say vim hello world.py, and I just want to write code which prints hello world. Right, and if I want to execute this particular code, all I need to do is Python. So all of this is in one particular folder. So in this particular folder, if I list all the files that are available, there's a file called hello world.py, and essentially if I type Python hello world.py, it just prints hello world. Right, so this is one way of executing Python code. You create a .py file, write all your code in that, and in order to execute, you just do Python hello world.py. So this is unlike C or C++, where you'll first have to compile, create an executable file, and then run the executable file. Okay, but again, Python is the advantage of Python is that there are many different ways of running this. So suppose in many times you don't want to just write all the code in one go. You want to maybe execute parts of it. It's an interpreted language, right? So at times you want to execute a part of it and then test only that particular part, and then continue executing the rest of it if it works out, and so on. Right? So one other way of executing Python code is using what is called IPython. Right. So this brings you to the following Python prompt, IPython prompt. So I can just so right now in this particular shell, Python shell, I can type Python code and execute it. So for example, print hello world is going to print hello world. Okay, so that's one way to sort of execute code, but it's sometimes clunky. It's not the best way of writing code, but let's say you just want to maybe run a couple of lines of Python code quickly. You want to compute something, then the IPython shell is extremely useful. You can just access it from the terminal. Now you can also use an IDE for Python programming. There's PyCharm, there is Visual Studio Code. So for example, I have Visual Studio Code installed over here. In Visual Studio Code, I can sort of load Python files. I can type them and then again execute Python code from the terminal. But a very convenient way of sort of running Python code is using what is called a Jupyter notebook. And that's a great feature because it also allows you to comment, add text, add sort of interchange between code and documentation. So it's a single file which contains both documentation for the code as well as your code itself. All right, and we'll just see how that particular thing works. Okay, so this is just a normal Python file. So when you install Python from using Anaconda, it'll automatically install it typically automatically installs IPython. It also automatically installs Jupyter Notebook. Okay, and there are different ways of accessing Jupyter Notebooks. The easiest way from the terminal is to just type Jupyter-notebook, enter, and this is going to open up Jupyter Notebook in a browser. Okay, so if you want to create a new Jupyter Notebook, I'll just click right so that you can see it over here. You just create new Python 3 Jupyter Notebook. Right, so this gives me this nice interface where I can type Python code. Right, so basically I can have multiple cells where I can type Python code. So for example, I can type print hello world, and if I do shift enter, then it basically executes this. There's an error over here because I did not include these in quotes, right? So I can type multiple things. I can type print 1 plus 2, and that enters this, right? So also, if you just have, say, one line, if you're just printing one thing, I don't really need to give print 1 plus 2. If I just do 1 plus 2, it automatically outputs what is there, right? But if I have 1 plus 2 and 2 plus 3, 2 plus 2, it only prints the last thing. It does not print 1 plus 2. So if I want to make sure that both things are displayed, then I do print 1 plus 2 and print 2 plus 2, and this outputs both. The nice feature about Jupyter Notebook is that so this is Python code, but I can also change the type of the cell. So this is code, there is markdown. So in markdown I can insert markdown code. So for example, I can type this is a Jupyter Notebook to introduce you to the basics of Python. Right? Notebook. Now this is not Python code. If I execute it, it creates this nice formatted text. So so all of this is written in a language called Markdown. It's a way of generating documentation. So down syntax, you can just look up Google and you can get the basic syntax of Markdown. You can have nice formatted text where you have headings, subheadings, items, and then and so on and so forth. Right, so it's a good way of commenting Python code to sort of add to describe what kind of code you're using. Suppose you want to describe the algorithm and then write code for implementing that particular algorithm, you can do that in a single Jupyter notebook. So a very good I would encourage you to sort of document your code well enough or get used to the idea of documentation. Because code in many cases is read more than it is written. Right, you will read your code after a long time. You could write code that is going to be read by a lot of people, so it always makes sense to write it well. Okay. So if you are using a Jupyter notebook, then you can add comments using Markdown. But even otherwise, when you're typing, say, code in Python, you can add comments using hash. So hash followed by some text. This is a comment. So this basically gives a comment. So if you want a single line comment, then hash followed by something is going to be a comment, right? Print x plus 1. Print, say, 1 plus 2. Okay. So right. So this line is not executed. You can also add multi-line comments in the following way. So 3 double quotes starts a comment, a multi-line comment, and 3 double quotes end a multi-line comment. So all of this text is a uh, right.